Okay. Week 2. Are you ready? Yay. So, this is not going to be a very lab-heavy week. A lot of this is the new stuff that's going to show up in the test. So currently, right now, the Linux Plus test is in flux. If you sign up for it right now, you can take the old Linux Plus test. But, I mean, I don't imagine anybody in here is that confident about their Linux skills, so I would not recommend doing that. By the time we are done with this class and y'all are ready to take the new test, it will be over this stuff. And Linux Plus has decided to go, or CompTIA has decided to add a bunch of the cloud native stuff to the Linux Plus test because, as we were talking about before the lecture, everything, Microsoft Azure, Google Cloud, Amazon Web Services, they all live, eat, and breathe Linux. That's where their main moneymaker is. Not on licensing or anything weird like that, but on support, on Amazon Machine Images, on all the features that people add, all the value add stuff to Linux. So if it seems like I'm just yakking at you, I kind of am, because it's on the test. It's on the test. But it's kind of a history lesson. So we're talking about cloud, we're talking about virtualization. You guys have already had about 4 months worth of virtualization experience. And what you're doing in VirtualBox is actually, the words might be slightly different, but that's enterprise experience. The stuff that y'all have been doing in VirtualBox is exactly what you do in VMware's ESXi, which costs thousands of dollars a year for companies to run. Zen, which is open source, but you can buy support. Hyper-V, which we just talked about, costs at least $600 to get on if you want server. You've been doing this. VirtualBox is this. The only reason VirtualBox is not a big player in the game is because their licensing is crazy. Oracle is crazy about their licensing, and they are hyper-vigilant about whether or not you're paying your dues to it or not. So people are normally pretty scared to run Oracle software, but if you've ever heard of Java, I'm sorry. they're not the greatest. But anyway, so a lot of this stuff you're gonna know. I'm gonna throw out some words that are slightly different in some hypervisors, but that's about it. So virtualization has totally been a thing since the early 2000s. Well, mid 2000s or so. That was its heyday. And you guys know, obviously, how it works. You just run a box inside of a box, right? You have Windows on the actual host server itself, or Linux on the host server itself, and then in a VM, you're running other Linux or more Windows machines or whatever it is, right? But they are full operating systems, right? You have to shut them down properly. You have to keep them updated. The care and feeding of a server is the same in a VM as it would be for running it on actual hardware. That is overhead. You've got to have someone to actually go poke at those VMs and make sure that they're staying up to date and all that kind of thing. Well, before VMs were ever even a thing, we had this concept of jails. So the BSD guys, so there's Windows, Mac OS, and Linux, right? Those are the main three that you hear about, especially when you're talking servers. There's also BSD. So BSD is very much like Linux, has the same typical heritage, right? Unix, and then some changes, and then BSD was born at Berkeley. Netflix is one of the few claims to fame that BSD has. BSD runs Netflix. That's all they do. Well, one of the biggest things that they do. And BSD came out with this idea of jails. And jails is basically a way to carve out a little section of your operating system. It is not virtualized in any way, but there's this idea called chroot, where you create a whole file system within your file system. So it's like VMs, but just files. So you're kind of blocking those off, and then you run an application inside that jail. The whole point of the jail is that whatever app you're running inside of there can't break out, right? It's an inmate in that jail, and it stays inside that jail. You can poke things out, like if it's a web server or Plex or Nextcloud or whatever, you can poke out like network stuff where people on the outside of the jail can access the application inside of the jail, but only by the rules that you have assigned to it. So if that was, all right, the only way you're going to get out of this jail is through this IP address and this port, and that is it. You cannot talk to it any other way. You can't touch it. You can't interact with it. It's only through this one portal that you can access this application. That protects the rest of your operating system. So if someone were to find some kind of hack through that portal that you have exposed, they can only blow up that application, which is still not a good thing, but the rest of your operating system is safe, which means that you can run that one application that may or may not have been exploited, as well as 7 other applications on your machine. They're all independent of each other. There is no crossover unless you specifically say there is. And you get that, essentially that protection. But the upshot to that is you don't have the overhead of running an entire system, right? You don't have to update the entire machine independently of the machine that it's running on. It's all one thing. So if you update the host machine, it updates all the jails within it. So removes overhead. But this came out before VMs. This was an idea well before, or like at least 5 years before VMs were around. And LXD, which we'll talk about here in a minute, has been around for ages. But yet, these things did not catch on, and VMs did. VMware made sure of that. They were one of the first. Anyway, so y'all know about VMs, and as web hosts, people on the internet, cloud stuff, as they needed to spin up a VM and then present it to you, and then, I want your $5 or $10 or $100 or $1,000 or however much you're paying someone for those cloud resources. As that became more and more popular in the later 2000s, we had to come up with a way to be able to just have like a template. So if someone says, I want an Ubuntu 18.04 server, buy. They purchase that VM, and that VM is available 30 seconds later. They do that by having a template and then just copying that over, slapping your name on it, and then just running that on one of their VM hosts. They give you a terminal into it, and there it is. But it's the same as everybody else's. Everybody else that clicked that button and paid their $5, your VM is identical until you start adding your customization to it. But at that point, it's out of the VM host's hands, and, well, depends on who you're with. But overall, yeah. I mean, you get your own viruses on it if you want to. Not a good thing. You'll be banned, but whatever. That's the idea. So that's where this comes in. OVA or OVF. Both of these originally pioneered by VMware. Thanks, VMware. But it's an open standard, meaning they posted the rules for free for everybody to take advantage of. But, I mean, for better or for worse, we're running on VMware standard. So they got that win, at least. But OVAs are pretty fantastic. If you want, there's a lab this week where you're going to be installing or utilizing an open virtual appliance. So OVAs are basically just one VM prepackaged up, stripped of any customization, and presented to you. You double click on it, boom. It runs in VMware Workstation or Open or VirtualBox, or you can even get them to run in KVM or whatever Linux runs on, KVM and Zen. Pretty much everything except Hyper-V, go figure, supports it. OVF, so OVA is a single appliance, right? It's in the name. Appliance, not appliances. OVF is a format to contain more than one appliance. So let's say that you have 6 VMs, and those all constitute different applications. One in this VM, one in this VM, one in this VM, one in this VM. This one's a router, this one's doing this one's doing that, whatever. But none of them work without each other. Right? So you wouldn't just take one VM out and then apply it in to a totally separate system. You want all of it. You'd have to have all of it. So that's what that OVF is about. OVF, you can check. All these VMs need to be contained in this one thing. And then you export it out. So in VirtualBox, the way that you would do that, right-click on one of these bad boys. Oh, you can't do it right there. Whoops. So, file, export. And then that's it. So if you select multiple, you're going to get OVF. If you just select one, you're going to get OVA. Hit next. Look at that. It's going to export it. You can choose your versioning. To be honest with you, 1.0 is good enough. So don't worry too much about it. And then you can decide, right? What if you're actually cloning this machine, right? You stripped it of all of its customization and you want to be able to deploy this machine. Anytime someone wants a VM, you just want to be able to double click on this bad boy and a whole new VM is up and ready to go. Then you wouldn't want the MAC address to stay the same for each of those VMs. Why? Why would you want the MAC address to change for each individual VM? Bingo. If it's on the same network, it won't be able to communicate. Right? You have two different MAC addresses for two different machines showing up in your MAC address table. Your MAC address table is going to get dumped over and over and over again, and your machine's not going to know, well, who has this MAC address, right? Because basic LAN networking relies on MAC addressing, and they have to be unique. So if you're moving it, you're going to remove it from this VM or from this VM host and move it to a whole nother VM host and then delete the original. You can keep the MAC address. It's probably better to do that, right? That way, if any kind of like DHCP leases or any kind of funky stuff that you've done on your network, that all still works. You don't have to go change anything.
So the VM we've been using,
Uh-huh.
like take them off our computer.
Yep. If you want to take them off your laptop, move them to your desktop, you can do that. All you got to do is export it. You got to wait because these things aren't small, right? They're like 8 gigs, 10 gigs, something like that. And then when you take it to the next machine, double click it. VirtualBox understands the OVA format, and it'll straight import it. That's all it does. And you've got the same VM with the same software at the same exact point that you shut it down at before running right in front of you. And all it takes is the time to write it to the disk. That's all it takes. So if you have the install disk still installed or still hooked up to the VM, it'll make a copy of that too. If you want. Don't do that. It takes a lot of extra space. Unless you have a good reason to do it, don't do it. Right? And you've got a few different options that you can choose here. Once you go through, it's basically just going to start the copy at that point. You can add some details to it, right? Like if you want more, if you want to name it, add some information, add a description, call the guy that you're giving it to names, whatever. You can put that in there if you want. But, right, this is where all the information goes, and then you hit export. And it'll export it right where you told it to. That's it. And you've got yourself a portable whatever. Put it on the computer, double click on it, and you're good. So, like I said, most hypervisors that work on the desktop will just import them. If you're running strictly from a command line or something like that, you got to figure out what the command is for that particular hypervisor, whatever it is that you're using. But yeah, so OVAs, right? You create yourself that one template and then just use it and 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 use it again. But randomly generate a new MAC, and then everybody can use that same template. I can't spell, apparently. There we go. Anyway, so Amazon does this too. But, of course, Amazon, they're going to call it something different. Amazon Machine Image. All it is essentially an OVA. And when you go spend $10 at Amazon, they're like, double click on that OVA. Done. You got yourself a VM now. But it's cloned from that template. But we weren't done. We needed more automation. All right? Just double clicking it and having a base VM is not good enough. So one of the cool things that you can do, so there's a gajillion options. These aren't even all of them. CloudInit, Anaconda, Kickstart, Puppet, Chef, there's Salt, there's Ansible, there's tons of different ones that you can use. But what it is configuration management. This is another one of those buzzwords, right? Like cloud was a big buzzword like 5 years ago. Configuration management. You put that on your resume, someone's going to hire you. That's how it works. But you actually have to know how to use one so that you can, when they ask you questions about it. Yeah, don't just throw it on your resume without knowing what it is. But that's the deal, right? Configuration management. You guys are about to get into a situation in NDS where you guys are applying policies to 100 different machines, right? And it's like, we're going to enforce a password policy of characters. You must have 10 characters or more for your password. You'll set that in group policy. All the computers in the domain will respect that after the next log out, log in, or reboot. Configuration management is the same exact thing, except for on the Linux side of stuff. Configuration management, at least in Ansible, is cool enough, Puppet and Chef do it all too, are cool enough that even though it's a Linux first thing, it also supports Windows. So if you are good enough, if you've learned enough about it, if you played enough with, say, Ansible or Chef, you can fully drop maybe not Active Directory, but group policy management, and then just do it all through Ansible or Chef or one of these other configuration management things. So there's an analog for everything in Linux. Everything that Windows has, Linux has something too. But there's a lot of text in there, so it's really confusing looking. So all of these configuration management stuffs, they all have their own language. The two most popular are YAML. And I can never remember if it's YAML ain't markup language or yet another markup language. I can't ever remember, but I think it's the first one. Either way, this is what it looks like. So you got a server that contains all these cool scripts that look like this right here. And then your server over SSH, which is something that is native to Linux, it always works. It is always available in any Linux that you're running. Doesn't matter what Linux it is. And Windows now supports SSH. So everything supports SSH now. Your computer will check in to the server, and it'll download a script that looks like that. And in this particular script, if the machine is in the group web servers, then it will open up port 80. It will support up to 200 clients. It will actually put a hard limit on that. It will say, I will accept 200 connections. It will tell root to install HTTPD, which is another name for Apache, the latest version of it. It will, looks like it's going to create some configuration file, or it's going to copy the configuration file here to here. It's going to restart that service, start that service, and restart it in case it goes down. All of that. You don't need to know how to run that. That is not something that we're learning. That's more of a cloud topic. You get into that later or whatever. I'm just introducing the idea to you that this is totally a thing. And think about it. You got a OVA from before, that pre-configured Linux machine. You pair that up with Ansible, and you can have tons of these scripts, right? If you want a web server, there's a script for that. What if you want a Plex server? You can do a script for that. What if you want a Nextcloud server? There's a script for that. What if you want it to be a Java host? There's a script for that. What if you want it to be a Minecraft server? Well, it doesn't matter. You can create a script for that. And so you pair those two things up. Here's what Amazon does. Amazon has their AMI, their Amazon Machine Image. They have tons of scripts that look like that. And then they don't even present to you, do you want Ubuntu? Do you want this? Do you want that? They just say, hey, you want WordPress? You want Nextcloud? You want this, that, the other, Minecraft, whatever? Click the button. Click Next. And what they're doing in the background is giving you the OVA, applying the Ansible script, and then presenting you a shell. And you pay money for that. But we can do it here locally as well. This is the technology that they use to do it. There's another way to do that, JSON. Jason. It reads like JSON to me. But anyway, Jason. And this is not similar stuff. I couldn't actually find a script. I don't use Jason myself, and I couldn't find a script that mirrored what Ansible was doing. But Jason looks like this. It looks like JavaScript. And JavaScript is the language that runs the internet, right? You hover your mouse over a thing on a website and a little panel pops down or something like that. JavaScript. Jason comes from JavaScript. Anyway, and so it'll look like that. You got a bunch of brackets, you got a bunch of this, that, whatever. So in JSON, the brackets will kill you. If you don't have the right number of brackets or them in the right spot, it will yell at you and it won't work. In YAML, the tabs will kill you. Notice how many spaces between one tab and the other, like vars and HTTP port. How many spaces is that? It's a fixed width font, so it's the same. So if it's VA, is the space in between there? It's 2. 2. So if your tabs, by default, tab is 8. When you tab, 8 spaces. right? You'll break your Ansible script. You will just break it. So you have to have it exactly right. So JSON will kill you with brackets. YAML will kill you with spaces. Whatever. I guarantee you it's going to be frustrating no matter which path you take. Puppet, which is, y'all might have heard us talking about FDLIC, a company here that does a lot of cloud-native stuff and a lot of on-premises stuff. They use Puppet. So they deal with scripts that look like that. They, how? Where?
I think they were using it in their browser to, like if you wanted to import your settings to another browser.
Oh, yeah, you're probably right. That's it very well could be. Because all it is a script. It just tells Firefox how to deal with the information that you're exporting and importing, and only in text, so it's super tiny. Yeah, that's exactly what JSON is, and YAML as well. Just a text file that represents do these things. Yep. All right, so still in VMs, provisioning storage. You guys know this. Whenever you're creating a new VM and you create a disk and you have the choice of dynamically allocated and fixed, right? Have you ever chosen fixed? I know I'd tell you not to because it takes forever to create the VM, but if you choose fixed, right? So dynamically, you next, there's no waiting at all. What happens in that situation is dynamically allocated means that when you're installing Linux or Windows or something like that, it is just adding it to the host disk, the disk that lives in your VM host. And wherever, right? Windows NTFS will figure it out. So if you're in the middle of installing your operating system in a VM, you're downloading MP3s and videos and writing on documents or whatever, your operating system will be chopped up. So you'll have the first bit of your operating system at the front of the disk, video, MP3, video, MP3, video, MP3, and then the rest of your OS is going to be after that. So the result is that your hard disk has to work harder to find stuff on the disk because it's on the physical disk itself in the host. It's all over the place. So that can, especially if you're running tons of VMs, cause real issues in terms of speed. Now, most of the time in our classes, we don't do a whole lot of VMs at the same time. It's usually one, maybe two at a time. So dynamically doesn't really affect us. But if you're running a VM host that's going to have a dozen VMs or more on it, you better be choosing fixed, because fixed will pre-allocate that stuff. It will basically take a chunk out of your disk and say, off limits. This is for this VM. So the upshot to dynamic is that you only use the space that you're actually using, right? So if you say 40 gig hard disk, but you're only using 8 gigs of it, that file is only 8 gigs. The virtual hard disk file is only 8 gigs. If you choose fixed and you said 40 gigs, 40 gigs. It is 40 gigs. That way, you're not ending up with fragmentation, right? Talked about fragmentation last semester. This is a kind of situation where that would really come into play. Yes?
If you have like a dozen, they're all dynamic, and you defragment that, put them all back in the correct place.
It helps. Yeah, it absolutely does help. Contiguous files will try to be contiguous in a defragmentation type scenario. But you got to remember, you're trying to defragment like 8, 10, 20. And I mean, VMs get massive. I mean, they can be 1, 2, 3, 400 gigabytes in size, if not bigger than that, depending on what you're doing. So while defragmentation will help, it's best to just not get them fragmented in the first place. So if you're in that situation, running a ton of VMs, just choose fixed in the first place, and you won't have to worry about it. Now, the reason I bring that up is because the book uses thin and thick provisioned, right? So y'all are used to seeing dynamically allocated versus fixed. The book, this is just another way to do it. This is how VMware mentions it. So if you're running on VMware ESXi and you come up to this question, it's the same thing you've already encountered, it's just called something different. Thin provision is dynamic. It'll grow as you add stuff to it, but it'll end up fragmented, which has an effect on speed. Thick provision is the same as fixed. It allocates all that space automatically, and tends to have better performance, but you already lose that space. Another pitfall of dynamic is that, let's say you've got a 200 gigabyte disk. Is the VM host going to stop you if you do, what did I say, 200 gigs? Did I say 200 gigs? 200. So if you have 200 gigs and you create 5 VMs at 50 gigs each, total that's 250. Is the VM host going to stop you? No, because those files by default, they're like 4 megabytes. What's going to happen is, if you fill all those up, you're going to get to that 200 gigabyte actual physical limitation, and then your VMs is going to be like, kernel panic, I don't know what's going on. I'm stopping now. I can't write stuff. So you've got to be careful with dynamic if you're running low on space or if you've over allocated your storage. That is something that you're going to run into, and it's going to be scary when you hit that limit and stuff starts panicking, man. And that's an actual term, kernel panic. Your Linux VM will literally kernel panic because it can't write what it needs to write, which means it'll halt. You've got to reboot, and it'll probably just leave a message. You know the blue screen in Windows? Kernel panic is the Linux analog to that. It'll leave you with a message saying, hey, something unrecoverable. It's broken. What do you want me to do about that? So that's what ends up happening. So either go with fixed or be very aware of how much space you've allocated under a dynamic scheme. Networking, again, you guys have encountered pretty much all of this. What I don't think you may have encountered is the bridged adapter yet. So I'm going to hit that one last. I know it's first in the list. I'm going to hit that last. So NAT, this is what you guys have dealt with every single time you spun up a VM. What it does, just like your router at home, it creates a local area network behind a router. VirtualBox is acting as the router. So when you turn up OpenSUSE, it comes up with 10.02.15 as your IP address. It's got its own router, 10.02.2. If you care to look, it'll show up. And it will go through that, and then it will utilize your actual network card to shoot stuff out. But the beautiful thing about that is that it prevents your host, the actual machine itself, from reaching into the VM and pulling out files. If that's what you want. You might not want that. You might actually want back and forth communication. You can do that through this. VirtualBox calls it host only. The book calls it local. So this type of networking allows a one-to-one connection between you and the VM, the host and the VM. Nobody else. You can't add someone that's not physically a part of your VM host to the network or anything like that. It is a one-to-one thing, internal, software only. But you can SSH into your VM if you'd like. You could push and pull files if you'd like, whatever you want to do. It is literally like you've got two computers facing each other and communicating. Yes, sir?
Isn't one of the reasons why it's not local because you can get viruses to your actual machine?
Mm-hmm. Mm-hmm.
You don't want that.
Yep. Yeah, that's why NAT is good. But remember, NAT is not a firewall, or really do not consider NAT protection. It does give you a modicum of protection, but do not treat it that way. Use the firewall as it was intended. It's meant for that. Because in a situation like that, while your host can't reach into the VM, your VM can reach out to your host. So there is one-way communication there. Just like the baddies out on the internet can't just reach into your home network for no reason, NAT protects you against that. But there's nothing stopping you from reaching out to the baddie and downloading their PDF that's infected with a virus, right? No one's stopping you there. So NAT really isn't protection, but it does kind of masquerade as it sometimes. So in that case, firewall. Firewall. NAT is not a firewall. Do not treat it as such. Use an actual firewall. But overall, yeah, it does give you some of that protection. But when you do a local host-only network like this, without a firewall, there is no protection. So you can push or pull a virus to or from that machine. You got to be careful. And then internal networks. So these are really handy when you want multiple VMs to communicate amongst themselves, but not outside to the larger world. So if you got 3 VMs, one holds the database, one holds the web front end, and then one holds maybe something like single sign-on or login information or something like that, right? Think Amazon. They do this. They have a ton of VMs running the web front end that you get when you go to Amazon.com. They have a ton of VMs running the database that holds Charmin versus store brand versus everything else. And then they also have login stuff. That is totally separate. But all those VMs communicate internally to hand you off from one server to another, back and forth and back and forth and back and forth. That's where these internal networks come in handy. Nobody on the outside can reach in and talk to any of these. But what you can do is dual home. You can set up a VM with 2 network cards. One that has access to the internet, that can talk to customers, things like that. Everything else is off limits. And then you have a second network card set on an internal network that will communicate amongst other VMs. That way, you can get extremely fine-grained firewall control on those networks, on those network interfaces. That way, only this type of information can flow out of this network interface. And only these IP addresses on those VMs can communicate to each other. And that's it. So, these are the ones that you are slightly familiar with. And you will get more familiar with them as we move on. This one is, I think y'all have used it, maybe not. But if you haven't, Bridged is quite literally turning your network card, your single plug network card on your laptop, your Wi-Fi, your desktop, whatever it is, that one network card, turning it into a software-defined switch. So that Cisco switch over there that works off VLANs and can do MAC address controls and all that kind of stuff. When you add a network or a VM to a bridged adapter, you are literally saying, all right, cool, yeah, change your MAC address, but use the adapter as it is. So if you attach a VM to a bridged adapter and then plug that network card into a network, that VM is actually on the network, the same as if you were to just plug a desktop into that switch, into that same network. The desktop would not know that it's talking to a VM. It's got its own IP address. It does everything identical to a real live actual physical desktop. At that point, that VM doesn't look virtualized to anybody from the outside looking in. It is just a computer. This is why when you go to Amazon.com, you don't realize that you're dealing with virtualization in containers. You have no idea. Is it a real server? Is it a VM? Bridging. Fancy stuff. So we'll use those every now and then. Bridge adapters are really good for performance, things like that, but they do expose you. You don't get that little bit of protection that NAT gives you. So you can run into some situations where you need to pay even more attention to the firewall on a bridged adapter. All right. So last topic in this virtualization area topic thing, containers. All right. This one's a heady one. Yes, sir. She may have been. That's very possible. There's a lot of crossover in some of these classes. So containers. If you haven't heard the word Docker, you will. Docker alone, just Docker. Not Docker Swarm, not Kubernetes, not all the other cool fancy things that are attached to Docker. Just knowing Docker signs your paycheck. Docker is the new wave of, you can call it virtualization if you want to, but it's not. Remember that Jails idea we were talking about earlier on, where you just kind of like carve out a section? That's Docker, but with extra features. So Docker took that Jails idea, which gave way to LXC. Now it's Docker. Docker is a way to pull down an image, just like you would an OVA file. pull down an image from the internet, and they just run an application, right? Amazon could very well be running their entire database, entire everything off Docker. You would never know. It could be a VM, it could be Docker, it could be native. I don't know. But that's the cool thing. So you only need a host. You don't need to turn on the virtualization extensions. Remember how we had to go in the BIOS and turn that on to yes and then whatever. Then you could use VirtualBox. You don't even need to do that for containers. And we were saying Amazon runs their web front end, their database, and their login stuff. Instead of using VMs, you can just use Docker. The cool thing about Docker is that there are orchestration softwares that allow you to utilize multiple servers at a time. So picture this. With VMs, you literally have to tie together the VMs if you want them to like share information, or if you want them to do that kind of handoff stuff we were talking about earlier. With Docker Swarm or Kubernetes, basically all you do is, let's say you got 100 servers, some here, some in Dallas, some in Austin, some in Houston, some in across the globe, whatever. You enroll them into Kubernetes. Takes about a whole 30 seconds to do that. And now, that Docker container, you're running the Amazon web front end, that will be added to every single one of the machines that you've enrolled into that swarm or the Kubernetes cluster, whatever. And let's say someone's trying to access your website from China. That Docker is running on that side of the world as well. So they don't come all the way over to Dallas and get to your website. They get it from China. All of those Dockers, all of those little containers are all working in tandem, figuring out where you're accessing them from, what kind of resources you need, and how to best get this stuff to you. So containers are better, and that's a debatable thing, but containers are better because you don't have to deal with how many cores do I give this container? How much RAM do I give this container? How much storage do I give this container? You don't have to answer any of those questions. You just Docker pull Plex, Docker run Plex. It's running. It's ready to go. If you want to configure it, you can deal with that. And I know I'm kind of making it sound simple, but I mean, to get it to just go so you can test it, it is that simple. Right here. If you want to run Nextcloud, which is like Google Drive, but if you want to host it yourself, after you install Docker, Docker pull Nextcloud, Docker run Nextcloud. It's running. You can log into it. You can start putting files into it and syncing it with your phone. It works. But there's this idea of transience in containers. So it's not virtualized. So you can run it on the craziest of hardware. So it's more open. And it's transient. What I mean by that is that, let's say you do Docker run Nextcloud, and you don't actually save it, you don't name it, and you Docker stop Nextcloud. Every single file that you put inside that Docker is gone now. Poof. It was all contained within that container. And when you delete that container, it's gone. All of it. Every bit of it. That was a head scratcher for me for a while, because it was like, well, then why would you even want to use it? Turns out, when you start a Docker container, you can answer those questions. Don't keep all the files inside of the container. Store them over here on this massive 100 terabyte network storage array that we have over here. So this happens for testing purposes. For I just want this application running for 30 minutes so I can test this thing real quick. So containers are great for stuff like that. But containers are also great for long-term deployments. What happens is, every time you want to update Docker, every time you want to update a Docker container, so you want to update Nextcloud from 15 to 16, and then 16 to 17, you literally have to tear it all down. That container goes away. The container is not necessarily reusable once you change version numbers. You pull down a whole new container, and then you run that container. But you tell it, hey, the data storage is over there. The configuration file is over here. All of the user database is right here. And then the container just runs the software. That's all it does. And all your other valuables are on a massive storage array that obviously has 2 backups because we're really good admins and we're good at our job and we keep good backups and we test our backups, right? Right? Because that's the important stuff. The software is not important. The software has become an implementation detail, and containers are the ultimate representation of that. Run it, throw it away, do whatever you want to with it, test it, anything. Keep all your valuables over here in this array, but the software, whatever, run it over there. So that's called persistence, persistent volume. You basically just tell Docker, data's over there. And then when you run it, it sees all your data. And when you destroy your Docker container, your data doesn't go away. It's persistent. Pretty interesting stuff. And as far as virtualization goes, it's not either or. You can run Docker in a VM. If it wasn't inception-y enough for you yet. You can run a VM in a VM and then a Docker in that secondary VM, right? Like you can go all the way down. You just keep going, like get crazy with it. But a lot of times, cloud providers will set up a ton of VMs and then install Docker on all of them and then orchestrate it all. I put Docker Swarm in there because I'm trying to be nice to Docker, but to be honest with you, Docker Swarm is trash and Kubernetes is where it's at. It kind of is what it is. Google wins. Kubernetes is a Google software that they open sourced about 2011. And once everybody got a hold of it, everybody threw away Docker Swarm because Kubernetes is way better. So so you have, say, 100 VMs, all running Docker, all part of Kubernetes, and you say, run Nextcloud. Your storage is over there. If one of those VMs totally blows up, what happens? Kubernetes figures it out. Throws out that old broken VM, starts up a whole new VM, adds Docker to it, and adds it to the swarm so that it can start sharing those resources again. So it is failover. You lose one of them, you lose 10 of them, you lose 99 of them. As long as one of them is alive, your Kubernetes cluster will hobble along. It'll make it. Might be slow, but it'll make it. So really interesting stuff. When people say cloud, when people say cloud technology this, blah, blah, learn this, learn cloud, they're talking about Docker and Kubernetes. So when I said earlier, you write your own check when you know Docker. I'm not kidding. That is for real. You learn Kubernetes on top of that, just add a few $1,000s to your check for funsies. That is cloud. That is what it is. That's what it means to do this. And then you have Google's Kubernetes and Amazon's Kubernetes and Azure's Kubernetes. So if you know how to use Docker and Kubernetes, you're good. When you go and your company says, all right, we got a gajillion credits with Microsoft Azure. Now all you got to do is figure out how Microsoft tweaked Kubernetes, and then you can run it through there.
So AWS, Azure, whatever Google thing is,
Mm-hmm.
it's all based on Kubernetes.
Mm-hmm. You can buy a full fat VM if you want. You can do that. Or when you say, I just want to run Nextcloud on Amazon Web Services, you're in a container. You're not in a VM. And you don't get full root access. You can't do your own updates or whatever. It takes care of it for you. So during your maintenance window, your container will be unavailable for about 5 minutes while they destroy your old container, shove in the new one, and start your services back up. That's it. Think of containers like Legos. Pop one out, pop another one in. It's good. It's all good. So that is your primer to cloud. Cloud is the new wave. No matter how much you like it or hate it or whatever. To be honest with you, I just hate the word cloud because I think it's stupid. But the technology underpinning it, Kubernetes, Docker, all that stuff, that is fantastic. fantastic stuff. Saves so much time and money. So anyway, that's why it's valuable. Booting.
When they change your level of access. Like if you go from, I guess, Amazon to Amazon Prime,
Mm-hmm.
is that what they're using to change those services?
That all happens within the database, I think. So that would be more of the authentication stuff. So think of it like Windows, right? Like when you're not in the administrators group, can't do jack. But when you get put into the administrators group, now all of a sudden you have UAC prompts and you can click yes on them. That's more what's happening in a situation like that. It's more of a permissions thing. But I almost guarantee you there's a container involved somewhere. All right, so booting. You guys obviously know how to boot a real machine and a VM. Most of that is this, right? You can do it with an ISO. You can do it with a flash drive if you're doing it on your laptop or a desktop or something like that. But it turns out you can also boot them over the network. There's a tech called PXE or Pixie. And you've probably seen it. If you've ever gone to an enterprise lab of any kind, you'll see during the boot, if it was off from the beginning, you press the power button and it says Dell. And then the next screen is there's a little slash that's turning and turning and turning and turning and turning and turning and turning. It's waiting for an IP from a Pixie server. If it gets one, it will boot into that Pixie server and then do whatever the Pixie server says to. And sometimes that is, oh, well, here's the installation ISO for Windows or for Linux, Ubuntu, CentOS, whatever. And then you're presented with the same screens that you've already seen a million times before, right? Pixie is just inserting the ISO, but instead of hard disks and flash drives involved, it's pulling it over the network. So y'all have probably heard TFTP by now in the Cisco classes. That's where you pull your Cisco images from. This is how some Cisco switches and routers boot. The image is not local on the switch. It pulls it from a network location and loads it in dynamically. That way, you just update that one image on the TFTP server, and the next time you reboot the Cisco switch, it's upgraded because it pulled that image on the server and loaded that instead. Same exact idea in Linux. If you're booting from Ubuntu 16.04, but you just updated that image to 18.04, now the next time you pull it down, it's 18.04. You're getting the new one. So you can do that over TFTP server, which is the old way. And I say old, but not dead. It's still around. NFS is another way. The biggest use of NFS shares when you're network booting like this is thin clients, where your computer has a little bit of RAM and a CPU, but not much else. No storage, none of that. It's pulling the entire image, the entire system image, shoving it in RAM, and then just running it. So there is no OS on your hard drive on the computer you're running on. It is dynamically pulling that from a server, sticking it in RAM, and letting you do your work. That way, any file that you save automatically goes back to the server. So, thin clients, pretty cool. Usually pay like $100 or so for a box, and then you just pay all the money that you would save instead of paying for desktops go into your server and storage and all that. You want to make it fast, etc., etc. The last thing I'll tell you is iPixie. iPixie is basically just an update to Pixie that allows FTP and HTTP as well. So this would allow you to point at, where you went to go download your Ubuntu image or CentOS image or OpenSUSE image, if you went out and downloaded it yourself. This would allow you to point a VM or a desktop to that image on the internet and dynamically download the OS as you boot. Totally would work. There's a minimal image for that Ubuntu puts out, so you don't actually have to do that, but it is possible. So under bootloaders, You only have to know these names. You don't have to know much about them. Know they exist. Lilo, the Linux loader. Really, really old. Some people just swear by it for some crazy reason. You find it a lot in distributions like Slackware that are very set in their ways from back in the 90s and early 2000s. But all it does is once the BIOS does its post to the UEFI, it will hand it off to the first stage bootloader. And that's usually Lilo or something similar. And then it will go around and find, all right, well, here's the boot image, here's the boot file, here's this, here's that, here are all the disks, everything else. All right, cool. Now Linux, boot. That's what the bootloader does. SysLinux, you find those a lot when you're doing the Rufus, right? Putting Ubuntu on a flash drive so you can install it on a server. You don't use Lilo or Grub or Loadlin. You use SysLinux. It is a customized bootloader for flash drives. Then you have Loadlin. This was really big back in the 90s and early 2000s when, in more 2000s, when you were able to, in Windows, install a pseudo partition, PSUEDO, not SUDO, pseudo partition on your Windows, or within Windows, and you would be able to reboot directly into Linux. So it's like dual booting, but with a lot less stress. You're not going to blow up your partitions when you do this. I mean, the software inside of Linux can do that if you're not careful enough, but overall, not so much. Grub. Now we're talking. Grub starts all three of the VMs that you have installed so far. Grub is the important one, but not this Grub. Grub 1 was created and added a few features onto Lilo. This one, Grub 2. This is the important bit. Grub 2 is the de facto Linux bootloader. Someone might argue with you on the internet, but this is it. Every single Linux VM that is in mainstream, the ones that you get from Amazon, the ones that you spin up yourself, they run Grub 2. So, the facts are on our side. Now, Grub 2 does exactly what I mentioned Lilo did earlier. It takes the handoff from the BIOS or UEFI. Inside of the boot directory is where your kernel lives. And right now would be a really good time for me to start up a VM. So while I'm talking about this, I'll boot this guy up. OpenSUSE tended to run the best out of all of them. So inside of boot lives your kernel. I will show you that here in just a sec. The main configuration file. Here's the thing. It could be under Grub 2 or Grub. It depends on your distribution and whether they call it Grub 2 or Grub. Overall, it doesn't matter. Just type in GRU and then tab, and then whichever one it finishes out as, that's the one it is. You don't have to know. You just have to know how to figure it out. That's it, right? A lot of this Linux stuff is very much like that, where, no, you do not have to remember the exact location. You just have to remember how to step there, how to slowly get there. Use the tab key. It'll save your life, I promise. So all the goodies exist in boot Grub 2 or boot Grub. Now, whichever directory it is, there's a grub.cfg. That will contain where the Linux kernel lives, what partitions exist, where all the system files are, how Grub is supposed to boot, like in what order the partition is supposed to come up, in what UUIDs all the partitions have. Just information about the boot process. If you need to do something funky, you've got yourself like a Wacom tablet that is not supported by Linux, but you need to load up a driver. You'll drop that driver inside of etc default grub.d. This is not something that you do often. This is just something that you should know. There is a spot where you can add drivers so that the bootloader will pick up on stuff. RAID cards are really notorious about this. So if you got yourself a really old, really old, or really new RAID card, there's a chance you might have to drop its driver into etc default grub.d. If you ever make a change to grub, to that CFG file that I mentioned before, you have to update it. There are two ways to do this. There is install grub onto dev sd whatever. So now that I've got this up, let me show you what I'm talking about with all this. It is. Well, hopefully the demo will clear some of this up. If you want, I'm totally happy on Thursdays to go through this stuff, even if it's just a recording. Send me all your questions in Slack, be like, add this to the recording, and I'll do it. And I'll make that available to everybody.
You know how long it took me to change my directories downloads?
4.5 minutes of actual trying.
I was legit trying. It took me about 15 minutes.
So, a point that Linux loves to make: everything is case sensitive in the terminal. Capital D and little d are two totally separate letters and will never agree. Yeah, forward slash versus backslash for sure.
Different variations with lowercase d, and it was the capital D.
Yeah.
First time I had it right.
All right. So, speaking of change directory, let's change directory to boot. So, let's see where I am right now. I'm in home Leo, right? Everybody's going to start there, or home root if you're crazy enough. Let's change directory to the boot directory. Let's see what's inside of here. ls will list everything inside. That is a little messy, so I like to add in -l, which will give you just one list on the right-hand side of all this stuff. OpenSUSE does what? SUSE. They're not /boot/grub, they're /boot/grub2. And this is just the way that OpenSUSE, the guys at OpenSUSE decided to do it. It reminds you you're running grub2. In Ubuntu, I believe it's just grub. Be aware. Do this. If you're not sure which one it is, go to /boot/grr tab, and it will figure the rest of it out for you. Yes?
So if you are in the downloads folder and you want to go to boot folder, you have to go home and then boot, right? Or you have to do ////.
So you were making the joke about relative versus absolute paths the other day. And if you use the absolute path, the full path, then it doesn't matter where you are, you will go exactly there. So let's do this real quick. Etsy, that's a lot. XDG, yeah, cool. Systemd, cool. Let's go there. So look at this working directory. I'm in, what was it, A? Yeah. I'm in Etsy, XDG, systemd user. That is pretty deep into the file system. You can go deeper, but I'm not trying to. And I want to go straight to boot. I cannot cd boot. Exactly. But that makes it the absolute path. You're starting at the very top of the file system. That represents the very beginning of the file system. Everything is inside of that /. So if I do this, if I just do tab, right, because it's ambiguous, it doesn't know what I'm talking about. There's bin, Etsy, lib64, proc, sbin. Remember that stuff we were talking about last week? There's a bunch of directories that have a bunch of stuff inside of them. These are them. And notice, boot's in there. So, BO. And I'm going to do tab because I'm lazy, but also because there's no ambiguity here. There's no other anything inside of here that starts with BO. Nothing else. So at this point, tab. And it'll finish it out for you. This is really important when you're typing things like this. Raise your hand if you can totally typo that. Me! That's me. Yep, 100%. I will typo that every single time. So I will type in VM Linux-4.12 tab and then try and finish out the rest of it. Because notice, there's that one, right? .tar.gz. And there's this one, -default. We were talking about libraries before. Look. VM Linuz, Linuz, points to this one, that kernel. So that's my actual kernel. But the system just calls it VM Linux. That way, the kernel can change, but the shortcut never has to. So we can always refer to it as VM Linux, and that's it. And it'll always point to the right kernel.
So you don't have to do CD/home/root/capital D download. You don't have to type that. You have to do CD/capital download.
Right. Yes, you're right. So let me. Right. So I just wanted to see. I just wanted you guys to see where boot was, and that's it. So you can CD/boot from wherever in the entire file system, and then you can LSL and find that same stuff we found a little while ago. So, but to your point, grub2 is inside the boot directory. So I can do this one of two ways. Since I'm already in the boot directory, it tells me this right here. Grub2 is inside it. I can just go cd grub2. I don't have to put /boot/grub2. Because grub2 is in the directory I am actually in, I can just say grub2. And then, boop, grub2. Notice it just added it to the back of that file path. Or that file directory path. Do an ls in here. You find things that you might need. What file were we talking about? Grub config, grub.cfg. This is where it lives. Permission denied. Oh, by the way, you guys know, as well as I do, that you won't remember sudo every single time. Obviously, I don't either. This is a way, sudo space exclamation point, that will rerun the last command that you just typed in with whatever on the left added to it. This will save your life. Now you can also do this, right? You can hit the up arrow key, get back to your command, and move the cursor all the way to the left, type in sudo, press space, hit enter. No, don't do that. This, sudo space, and yup, it's weird. Bang, bang. They literally, yes, it's a thing. Bang, bang. Sudo bang, bang. If you ever hear anybody saying that, that's what they're talking about. Sudo bang, bang. Or sudo exclamation point. So much easier to say, though. Yes?
Is it bad to use sudo for everything that you type into?
Yes, because using sudo for every command would be no different than just straight logging in as root. And that's dangerous. So, like...
I couldn't remember, like, when do I use sudo? Screw it, I'm going to use it for everything.
And I totally get it. So what you should do in cases like that, when you don't know when to use it, is to just run every command without it. If it tells you permission denied or you must be root or whatever, then sudo bang bang. That will just 7 characters will save your life.
So, like, if you hit sudo on there, that's just for the one command that you
Correct. Yes. And so sudo is taking that you should never be root to its ultimate conclusion. Always be your regular user. Always. And on that one thing that you need to run as admin, okay, cool, sudo. But every other command, you better not be. Because you can do some funky stuff. I mean, you can delete the entire contents of the Etsy directory, which is extremely important, without thinking. I mean, it takes a whole 10 characters to do it. That would be bad. That would be really bad. Okay, maybe 12 characters. But still, you would need an RF. So, I mean, maybe I'll take a snapshot before we go and I'll do it. But, so sudo rm-rf Etsy. Boom, the whole Etsy directory gone. Every bit of it. Oh, right. Yeah, some trolley website out on the internet. It's like, here's how you install the Apache server. Run this command first. Dead. Yep. But this is no different. You know, people like to tout Linux as it being a super secure distro, but like, look at this. This can kill your system. This would kill it. You would reboot and you would never boot again. I mean, unless you reinstalled it or replaced it or had backups or whatever, right? But, at that point, you're already in the, tiny percentage of people that actually keep backups, right? But yeah, I mean, that could totally blow up your system. So this is really important. It's important to know what you're typing in. And if you don't understand what you're typing in, ask me. Ask me. Or ask the internet if you don't want to ask me. Or ask your friend if you don't want to ask the internet. Or whoever, right? Just know what that means before you hit enter. Otherwise, you're going to end up in a real world of hurt, right? Or take tons of snapshots. I don't know. And then just run everything.
I don't know if you ever went through the snapshot or anybody ever went through it. I just happen to know it for some reason. But, in the book, it addresses snapshot.
Oh, good.
And it says that like snapshot is your best friend and you get it.
Yep. Yep.
So if people don't know
Well, I say that earlier. And
how to do a snapshot.
yeah. Okay.
I just happen to know.
All right. So if I wanted to run this command, full well knowing what it does, just to see what would happen, take a snapshot first. Right here. Machine, take a snapshot. When you click it, it asks you to name it. Name it whatever. Let's name it right before I kill everything. Hit OK. Right? It doesn't take very long, especially if you have an SSD, maybe a couple seconds. Watch, it's going to prove me wrong. It's going to be like 6 minutes. Oh, there it goes. All right. And now, without thinking twice, I can run this command, blow away Etsy, and see what a Linux machine would behave like if you were to do that. Hint, it won't be good. But, when you get to the point where it's like, okay, well, I'm done playing around now. I should go back to when it actually worked. You can just close it. This checkbox right here. Look at the name of that snapshot. And that will restore it back to right there, right where I left off.
So that's like manual saving the game.
Yes. Yes. There are no quick saves. You gotta actually click the save button. And that's exactly what it does. You're right. Think of it that way. A save in a game. That's exactly what it does. Yep. So,
Having to reinstall your whole system.
yep.
Last semester, I did a whole lot of reinstalling.
Oh, yeah, exactly. Snapshots.
Snapshot.
Yeah. Snapshots will help you not have to reinstall your system as much. Yeah. Yeah, screenshot is just a picture.
Yeah, but that's what I thought it was.
Oh. Well, they have that too, I think. They actually do. There, take a screenshot. So they do have both. You can do that too. All right, so let's look at this configuration file real quick, and then I'll double down on that downloads thing. All right. So notice, I do it, and then it reminds me what it just did. Because it's going to ask you for a password, and you're like, oh God, that wasn't the actual command I wanted to do. Because you're kind of doing this blind, right? If you accidentally did another command before you ran sudo bang bang, yeah, bad. It could be bad. But it reminds you, before you run it, what it is. If that's cool, all right, now we can look at this file. Right, you don't have to know much about this file. It is not part of the test. Knowing that the file exists is part of the test. That's it. But the cool stuff that you can do in here is if you're doing something like dual booting, like you have OpenSUSE, CentOS, and Ubuntu all on the same hard disk, this is the configuration file that you would go and you don't manually edit this either, by the way. You would go in and actually, you could, if you wanted, to do that. But there are tools that you can deal with to do all of that. So cue to get out of that if you did do that. All right. So last thing I wanted to, the capital D downloads thing. That little squiggly, remember, is a shortcut for home, my home folder, specifically my home folder. See? Home Leo, right? So let's do ls. Ooh, look. I got a downloads in here. You probably already ran into this situation, but CD downloads does not work. CD capital D downloads totally does. The way you check yourself before you do this is get it on unambiguous, right? There's nothing else in there that starts with DOW. Tab. If it doesn't tab complete, it ain't there. right? So let's do CD, totally unambiguous, down, tab, nothing, tab, nothing, tab, 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 nothing. It doesn't exist. Does not exist. So if you are, I don't know, if you get your feelings hurt easily and you don't like it when Linux is like, that directory doesn't exist, just tab and it won't tell you anything.
Do you have to have the backslash even if it's capital B?
No, you don't. Tab put that there for me. The autocomplete put that there for me. Oh, it would work. CD downloads, bang. It would totally work. The reason it puts that slash out there for you is so you can keep typing more directories. And you don't have to actually reach for the slash. It's being nice. Yeah, right? Yeah, it is. Yeah, it's pretty terse. Can come off as mean. That's what I was talking about with the whole, if you don't want it to yell at you. All right. So, last thing, and then I'll do a quick reboot and show you the grub stuff, is let's look at, this is a command that's going to save your life a lot. It's going to show you all of the partitions and disks that you have on your system. Right? Doesn't give you much more information than that. It just tells you got one disk, SDA. It's got 3 partitions. SDA1, SDA2, SDA3. This is very much like Windows in that... Oop, wrong one. If you want a graphical representation of it, notice this, right? Partition 1, Partition 2, Partition 3, Partition 4. Very much like that. That's exactly what this is telling you. And then how big they are, 8 megs, 20 gigs-ish, 1.4 gigs, so 2 gigs-ish. And then SRO represents a CD drive, right? Every VM has a CD drive because otherwise we couldn't insert the ISO. Totally. All right. It's important to know because this is a very important partition. It's it's normally out on its own because it can't be encrypted. You can encrypt your regular partition, which is this one, it's this one. You can encrypt your regular partition, but you can't really necessarily encrypt boot because the BIOS, which probably doesn't have the keys to your encryption, needs to be able to hand off to grub, which lives in the boot directory. The reason that's important, getting a good idea of how your partitions are put together will save your life when you do this. Oh, see? Sudo bang bang. Bingo bango. All right. So it reboots, and it drops you here. Here. Wait for it. Here. All right, still waiting for it. What's that? So on Thursday, nah. I'm going to kill it. Hey, I took a snapshot, so now I can totally freely kill this thing, and it'd be fine. If it breaks anything, I can just go back to my snapshot. So, in the interest of time, do not do this, please, especially if you don't have snapshots. But in the interest of time, so SUS is nice, and it drops you here to begin with. So you can come down here. The book mentions the C key, and it's important because the C will drop you down to, ooh, look at that. At the very top, what version of Grub are we using? 2. Yep, it's important. So, LS. Remember what we were just looking at before? SDA 1, SDA 2, and SDA 3. So this goes deeper down. Grub doesn't care whether your disk is over SATA or over IDE or SCSI or whatever. It's going to call everything a hard disk. So what you can do is LS, just like they have it, HD0, comma, do a couple tabs. I did it twice, so it's up here twice. Let's check out my mouse here. It says no known file system. So not GPT-1. File system. Yay. All right. Maybe that's it. GPT-2. GPT-3. No known file system. All right. Well, we whittle it down. The only thing that Grub can figure out anything about is GPT-2. So that's the one we're going to use, and I'll show you what I'm talking about, use. So GPT-2, and it'll tell you about that partition, and you can look inside the boot directory. Does this look familiar? We were just looking at this stuff. Grub can't do much more than look for boot files, because that's all Grub does. All it does is boot things. So what you can do from here is verify which kernel you might be booting into. You can swap them up if you're astute enough, not part of this test, not part of the Linux Plus test, so we're not going to worry about it. But you can at least verify what's going down. Now, looking at all this, lucky for us, we haven't done a ton of upgrades, but as you do more upgrades and get kernel updates and things like this is going to get kind of confusing, because it's going to be, 4.12.14, 4.12.16, 4.12.20, 4.12.22, 4.12.50, 4.12.100. Depends on how many times they issue new kernels. But the idea is that you're going to have a ton of these in here eventually. You should clean them out periodically. But that number right next to VM Linux or VM Linux is the version of your kernel. That is important. Because if you're on a newer kernel and your system's not booting, you're going to have to go back to an older kernel. So knowing how to figure out which kernels you got, kind of important. And this is one way to do that. So if everything is good, you can just type boot and it'll boot the rest of the system, or so I think I remember. But getting into this point and verifying your kernel is pretty important. I need to, okay, so don't worry about that. You can do, I think you can do reboot at this point. Yeah, okay, so just do reboot. And then it'll continue on. You can go down to advanced and choose your kernel this way, so you don't have to do the grub way. This is a lot easier to deal with. So if you have multiple kernels, you can go through them here. Otherwise, just boot the thing. And if you catch it fast enough, it'll tell you what kernel you're loading into up at the top. There's a lot of different ways. But in the lab, not that one. Two labs. This one is super easy. Please enjoy your free 100. Download the Kali OVA. This is going to be a fourth VM. You do not have to keep it. You can just load it. Once it's loaded, take your screenshots, delete it if you want. Yes, sir. Yours. No, that's a VM. VirtualBox itself is the software that runs all the VMs. So just open up. Well, you don't even have to do that. Just double click on the thing. So download this OVA. It's the whole appliance, the whole VM, all packed up, ready to go. Download that, double click on it, boom. You are like loaded into a fully installed, ready to go version of Linux called Kali. It's gonna complain because most of y'all haven't gone in and installed the extension pack. I never tell you to, I tend to run without it. But it's gonna complain about USB. So you can fix this one of two ways. Go into the settings of your VM, go to USB and uncheck this box. It's not good. Mine's running, so it's grayed out. Uncheck that box and click OK. Run the VM. That'll fix it. Or you can install this thing. Download it, double click it, install it. That's it. That will fix it as well. Either or. Disable USB because we tend to not use it, or install the extension pack. I don't care how you fix it, so long as Kali is running by the end of the day. Log in with root as the username, Tor as the password, show me the desktop, right? Once you log in, that's good. And then show me uname-r. So run this command in the terminal. That will show you the kernel that you're currently running on. See? Really, the kernel is really important. So being able to find it and see it and figure out information about it is really important. So anyway, take those 3 screenshots after it's importing, after you've got it logged in, and after you run the uname-r command. Easy A, I promise. These are links though, Kali OVA for that first one, and the extension. I should move those up. Those are just links for that first lab. The second lab, a little more involved though. What I just showed you guys on OpenSUSE, catching it at Grub, getting into the command line, listing your hard disk partitions, listing the boot information or the boot files inside, taking screenshots all along the way. So right here, when you get the thing to list all the partitions, show me the info that you use to identify your partition. Right? So I just want to see the list of all the partitions, and it'll say, file system unreadable, file system ext4, right? That's how you figure out which one to use. Now, for the love of God, that's probably not the command you're going to use. I can't tell you exactly. It might actually line up. It totally might. Can't guarantee it. So you have to use your noggin to figure out which partition boot lives in. It's the one that Grub can read. So, figure that out. Do ls whichever hard disk plus whichever partition /boot, and then take a screenshot. But what I want you to do is like either circle it or highlight it or something, which kernel is the most recent. So essentially the biggest version number, right? So if you got like 20 of them in there that are like 4.14, whichever one is 4.14 dot the biggest number. That's the most recent one, and that is by default the one you're going to boot into if you just let it boot. And you do that for all three. The process is generally the same, but Ubuntu and CentOS Ubuntu and OpenSUSE like to use GPT, like I was doing earlier, and I think CentOS likes to use MS-DOS. So you got to use your noggin. Yes, sir.
So you want us to go to the boot screen to look forward, right?
Mm-hmm. Yep.
Not what we were doing earlier.
I want you to get down to that Grub thing where it says Grub and it says Grub version whatever up at the top, and then you have a command line and it straight up just says Grub. That's where I want you to be for every single one of these screenshots. Yep.
Not in the actual link cell. Because we were doing when you showed us how to download.
Oh, right. Yeah, correct. I want you in, not the GUI at all. I want you in, I think it might actually reboot this time. Come on. I blame the VM. But yeah, where I caught it before it actually booted up into the system, right here. And you'll want to hit C, right there. Your screenshots come from a screen that looks similar to that. All of them. The way to get to Grub is slightly different between all three of them. But once you get inside, the info and the way that you figure things out is the same. So Grub is Grub, but different distros like to play tricks. In this one, it was C. Well, for all of them, For OpenSUSE and CentOS, it will be a C. For Ubuntu, you just gotta like smack escape a bunch of times and then press C. So I've got those instructions in there. It does give you a general idea of how to get there. So don't sweat that too much. But if you don't see a Grub prompt, you're not gonna get the right screenshots. So make sure you see a Grub prompt.
Doesn't matter if the C is capital. No, I'm joking.
In that case, it doesn't. Yeah. All right. So that's it. Look at that, guys. I only went 2 minutes over. Yay. Well, thank you for coming. I appreciate it.